Hello, this is a note for our Inland and Coastal Navigation course. Just some notes on working Quiz 4. Again, users can decide how much of these hints they want to use themselves and how much they want to just go ahead and work the quiz on their own. But here are some notes. So let's just take a look at working this quiz, and then we'll go on from there. So let's say I turn this quiz on. So the first thing with any of the quizzes, you want to read through the special instructions, general instructions, and then I don't see any when you have all the answers. See, what we want you to do is when you put all your answers in, then you want to come back and print a copy of it so you have a record of what you submitted with your answers on it. Not just your worksheet that showed what you transcribed onto this page, but you actual put in your answers here, then print it, then we see what the situation is. So let's look at this. Let's look at some of these. We've had some snags on this quiz, and so we want to just put a little more background on it. Okay, it says in this brief deviation table, and there's links to it, what is the deviation at 200 C, 200 compass course C? Be sure to indicate east or west. Okay, so what is this? That's the table. Okay, so let me go up here and make a copy of that we can work with. Okay, and then go back to the quiz. Okay, so there's the quiz and here's the table, and we want to know what the deviation is at 200. So what we have here is, here are the compass course. This is what the compass reads, exactly what the compass reads, and then this is the true magnetic. So what this number here, the difference between these two is the error in the compass, the deviation. So we know what these errors are. It's a difference between those two. It's like this one's easy. This one is 10, right? I can write that in. And this one is 4, whatever that is, 4, something like that. And so, and then this is they want compass 190, but this little table starts out only with 200. And this is often the case when you have a deviation, you're going to have a correction table, and often you have to interpolate it, and that's what's going on here. So here's 190, which is very nicely halfway between these two. So we know then, so what's the deviation? Oh, okay, so we know it's 10. See, the deviation is just always the difference between the magnetic and the compass. The magnetic and the compass. This is the true magnetic direction on the Earth, and this is what the compass reads because and it's not exactly right because it has some disturbance of some kind called the deviation. All right, so what's the difference here? Oh, and then we need to know which way the correction is, and we have a rule that covers everything. It's called correcting ad east. Correcting ad east. So we're at 200, and correcting means going from the compass to the magnetic. Because in a sense, this is the proper one, this is a magnetic one, this is a compass one that's been disturbed, so it's not correct. So correcting ad east, we want to get to the correct one, correcting ad east. So this is the 10 degrees, but what is it, east or west? And ad east, well, it's obviously east, because how do we get from here to here? We add this deviation, we add it. So this has to be an east, right? So that's the east. Likewise down here, we go from 180 to 184, correcting ad east, so that has to be an east. All right, so we know those deviations. And in this short range, this is going to be east as well, right? Because we don't 100% know that, but the compasses are not going to vary between this much. They're not going to bang into west and then back into east. They're not going to do it. They're all smooth curves. So whatever this one is, it's going to be east. Now, what do they ask? What's our question here? What would be the deviation at 200 C? Well, I'm going to go with 10 east. Okay, so that's what all that one is. So what here, using the brief deviation table, that's the same table. What would be the magnetic course we would be steering when the compass reads 190 C? So, okay, so we're reading 190 on the compass. We're reading 190 on the compass, and we want to know what the magnetic would read. Well, in principle, you could just take the halfway point between these two. That should be the right answer, right? Or we could also say, we could take the could figure the deviation here, and this is going to be, that's 200, that's going to be halfway between those, so we know what this is 7 east, right? 7 east here. Different, yeah, just, it's interpolating. I'm interpolating. This is 10 east, that's 4 east, 200, 197. So this is going to be 197, right? 197. Now, you could also, 197, you could also just take a calculator and just say probably 210 plus 184 equals 3, that divided by 2 equals 197. That's another way to do that one. Okay, let's move on here a little bit. I don't think we need that. We'll just keep that going for a while. The hand bearing compass shows a bearing range to be 227. The chart shows the bearing of the range as 216. True. Now we're not dealing with deviation anymore. We're dealing with variation, and that's the difference between true and magnetic. The proper magnetic, we're forgetting deviations. Deviation's already taken care of, and you're now dealing with magnetic, and you're comparing magnetic direction to the actual true direction. And the chart is going to tell us the true direction. And the chart, okay. Now, here's the other assumption in this type of problem. We are assuming that the hand-bearing compass is reading the correct magnetic bearing. In other words, we're believing that the ship's compass, the ship's compass, could well have some deviation in it. But we're assuming that we have a hand-bearing compass and we don't have any kind of watch on right next to it or steel rings, and we're not holding it up to steel eyeglasses. Nothing weird like that. We have a nice clean hand, nice clean compass so we can read accurately, and we're on a non-steel boat. Hand-bearing compass flat does not work on a steel boat. That I know of. I can't think of it. Okay, so we have a non-steel boat. You got aluminum, you got fiberglass or wood, something like that. And you're standing in a clean place where the compass works right. Now, it's not always true. Even on a fiberglass boat, you could have some kind of weird configuration or some particular place that's not working properly. Or I've seen cases of fiberglass power boats, and you stand outside of, you go out the pilot house on one side, you take a very nice bearing, it works fine. You go outside the other side, it does not work at all. And maybe one's because right next to where we're standing is a big old radar or something. I don't know. But anyway, so you have to check. But if you want to be sure that a hand-bearing compass is going to work right on the boat, then the first thing you have to do is test it. And that's just find a nice distant landmark, and then take a bearing to it, a sharp point that you can identify clearly on the compass. And take a bearing to it, and then you only have to do this once. You don't have to do this always. You're testing a place on the boat, so you just stand there and you take a bearing to some distant landmark, and then you note what it is. Like, well, this says some 227, right? It's a range. That's even better than a distant landmark. That's two things in a line. So you're really defining a line. Then what you do is slowly turn the ship. So you're now headed one direction, then you turn like 45 degrees to the other direction, to the left or right, and then you take that bearing again. That should stay the same. You turn another 45, take a bearing from that same place, now assuming you can see it still, and then you go all the way around. So that means if you're looking for a nice place where you're going to do your test, then you really want to be a place where you can see the horizon all the way around, or see your test mark all the way around. And then you keep going. And if you swing ship all the way around 360 degrees, and that bearing is always the same, then you can say, I've found a place where my hand-bearing compass works right. And in our course, we're assuming that you've found such a place, and we very often do examples or quiz questions where you're basically checking your steering compass with a hand-bearing compass in a clean measurement. And with that long story, that's what's going on here. Okay, so you have a hand bearing composite, shows a bearing range 227 magnetic, and the chart shows the bearing and the range is 216. Okay, that's easy. We got the two numbers we care about. The difference between those two is the variation, right? And then here's this little one sentence explaining that long paragraph I just read, or not read, I spoke. All right, so we got 227 minus 216 equals, that's 11 degrees. So 11 degrees, that's one of our answers, 11 degrees. So we know that's A or B, but now you have to decide, is this east or west? And so the rule is correcting, add east. Now, in this case, correcting is going from magnetic to true. We want to know the true direction to compare with charts, and we're starting out with a proper, correct magnetic direction, and we want to get to the true direction, and that's the correct one. So now correcting is add east. So when you go from 227 to 216, correcting, add east. Well, I'm not going to be adding 11. I'm not adding 11 to this. That would be 238 or something. I am subtracting 11. So if it's correcting, add east, and what I have to do is subtract, then it's got to be west. So correcting, add east would tell me here I've got to subtract, so it's west. So that one phrase, correcting, add east, should in principle solve all of our problems. We just have to think through what's correcting, what is correcting, and in a sense uncorrecting changes east to west. Correcting, yeah. So I get 227 minus 11 is 216, so it's west, so forth. Okay, so that's a couple comments on this type of problem. I'm going to leave that and then the rest to be worked out.